Hello and welcome everyone. Our today question is maximum connected group. So a group is the four dimensional component of ones and we have to tell the maximum connected group. We can change 1 0 to 1 and we have to tell the maximum connected group. So in this we can change 1 0 to 1. So its prerequisite is a flood fill. I hope you are familiar with this. So let's build the approach. So our first step, when we encountered anyone, so we have to make its neighbors colored with 1. So these components we have to color. So for this we will maintain an visited array of the same dimensions. So this is the visited array. So it is type of integer. Why I am taking integer? Because its default value is null of visited. Why I am not taking a boolean? So I will tell you why I am not taking boolean, I am taking integer, because we have to fill with color and we have to tell the color component. So we have encountered first one here. So color up its neighbors with a color component, with a color variable. So this is the neighbor. First color component I'm taking is 0. So here all the values starting null. So color neighbor component with 0. Now our color increases because we have filled one component with a color. Our next component is this, but as you can see, we visited this index. So let's jump on to the next one. So this is the next one. So fill up its neighbors. So this is the neighbor and we have to fill it with color variable. So color, 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 we have colored up. Next, increase your color variable and found the next unvisited one. So this is visited one, this is the unvisited one. So fill up with color. So this, now increase your color variable. Next is one, but this is visited. As you can see here, we have a value, and on the unvisited cell we have default value as null. So that's why we are checking. So it is visited, and now this is unvisited. So fill up with color. Now increase your color variable. Our next component is this. So fill up. I will apply DFS here, and our next component is this. But before that, we have to increase our variable. So this variable and its neighbors is this. So we have filled up, and our color variable having value 6. So we have filled our visited array with colors. So this is the color number 0 component, this is color number this component, and that's it. So this is the first step. So what is the first step? Fill visited array using approach flood fill with value color. So what is the next step? So while maintaining this visited array, we have to also maintain an array which will tell us the size of the component. So we have a list of integer and its name is size of the component. Size of the component. So we have to also and fill up your size of the component list. initially it is empty, our list initially is empty, and first we have this component. So we have filled up this component, and while applying DFS we will also return the size of the component. So we have an list. So the first size is 5. Then our second component is this. Second component is this, as you can see, its size is 3. And our this component. So we have maintained zero base indexing. So this component, its size is 2. And our next component is this, its size is 1 only. Our next component is this, its size is 3. And our fifth component is this, and its size is 1. So we have maintained a list also. So while applying DFS or flood fill, we will return the size of the component. So it will return us the size, and we will store in the list variable. So as you can see, zeroth component and its size we have at the list. So our next step. So we have filled up the ones. Now we have to find the zero. So we will run again a loop of n cross n size, and we have to find the zero. Find zero, and remember this only, the first step is only we have to do for ones. So for one cell we have to do, and this is we have to do for zeros. So there may be a chance that zeros are not there and only ones is there. So you have to maintain answer variable starting from here. So we will maintain an answer variable, and we will update our answer variable on every component or and we will store the size of the component in the answer variable. So our next step, when we encounter an zero, so we have first zero as this. So let me use another pen. Our first zero is this. So we can change up this zero. So we have 1, and we can also connect the upper component, this component, this component, and this component. So if we change up this zero, all the ones of the neighbor is connected. We can connect all up its neighbors. So when we encountered a zero, so just check, we have to add 1, and just check, is upper inside the boundary? No, it is not. Is the left side inside the boundary? Yes, it is. And what is the component? It is the zeroth component. So first store your 0, and if we go down this component, its component is 2. Then this component, then its color is 1. So 0, 2, and 1. So zeroth size is 5. As you can see, its size is 5. Zero size is 5. We can get it from this list. And 2 size. So this is the 2th component, and its size is here. 2th component. Oh, sorry, 0, 1, 2, 0, 1, 2. Its size is 1. Yes, its size is 1. So we have 1. Then for one component, this component, so it is the component of 1, and its size is 3, as we stored in the list. So take 3. So if we change this 0, we have a connected component of size 5 plus 1, 6, 7, then 3, 10. So we have this component of 10 size. So we have an answer variable, and its value is 10. So can we change this 0? So if we change this 0, then we have one component, and on the neighbors, let's check the neighbors. If we go up, we have this component 0 component, so 0. And if we go this direction, we have a component of 0, and we don't have to take this component because we have already considered this component. So why you are considering again? So that's why we have to make a set here. And if we go down, we don't have to make this component again. So we don't consider this component again because we have already considered while going upside. Then if we go this side, then we have component of different color. So this. So if we change up this 0, we can connect two more components of 0 color and 2 color. And 0 color size is 5 and 2 color size. So this is the 2th color and its size is 1. So 1. So we have a size of 7. If we change this 0, we have a size of 7. So it is not the maximum. So let's move to next 0. So if we change this 0, we have upper component of 1. So we have 1 here. If we consider this component, its component color is different, so we can consider it 2. And then downwards, its component color is 3, we can consider it. Then this component, so we have already considered this component on the while going upward side direction, so we don't have to consider again. So that's it. We can consider 3 components. So one size is 3, then 2 size is 1, 3 size is 1. So now its total is 6, so which is not the maximum. So let's move to next 0. So our next 0 is this. So can we consider this component? Yes, we can. So its color is 2, which is different. And can we consider this component? Yes, we can. Its color is 0. So can we consider bottommost component? No, we cannot, because it's null. So we can check a condition here, or we can fill up in our answer list, or if the value is null, then we don't have to find the value. So let's consider this value. It is null, and our next value is this. Its color is 3. So 2 color component is 1, size is 1. 0 color component size is 5, and we have null, so we cannot check its size. Then we have 3. So 3 colored component size is 1. So its summation is 8, which is not the maximum. I think the maximum answer is 10, and that's how we will find our answer. So what is the next step? Next step is to iterate and maintain a set variable. So this set variable contains our integers, and its name is different color component. Different color component. Then we will iterate in the different color component, and we will find our we will take summation of size of component, size of this current color component. I know this question is a little bit tricky, and I have told you the easiest approach, and at the end we have to return our answer variable. So we will take this answer into consideration, and suppose zeros are not there, we have all the ones, or so we will take answer here also. So we will consider answer here and update our answer. So let's code it up. So first we have color array, color variable, and n and answer. Then we have visited list. I am taking integer, and we will fill our color here. Then we have size of the color. So this will tell us the component size. So this will tell us the color component size. So then we'll run a loop, and if the one is unvisited, so the value must be 1 and it must be unvisited also. Then find your component. So we will apply flood fill here. I hope you are familiar with this. So then we have ij and visited color. So this is the base case. If we are iterating on the invalid index, then return 0, or if visited, if we have already visited this index, or if the value is 0. So we are only iterating, we are only considering one groups. So then fill up this current. So fill up this color value into our visited array. Then size of the component, we have to also return, remember, we have to also return the size of this current component. Then we will go up, right, down, and top. So after iterating, we have to return the size of this current component, and we have to fill into our answer list. So we have filled size of the color component, and we have filled up this component color. Then we have to maintain our answer list, and one thing remain, we have to increment our color variable. Then we have to run a for loop for 0. So if the value is 0, then we have to consider the different colors. We can take from going up, left, right, down. So we are going up, left, down, so all four directions, and we have to take the color. So visited array contains the color. So we can change this 0, so we have one size, and we can also combine the component of the direction of the flowing directions. So we have different color, and this color have color, this have color will tell us the components. If it is null, as I have already discussed, if our neighbor is 0, so we don't combine this component. Else we can combine this component and its size we have into our list. So size of this color component, then we can update our answer. So after updating, we have to return our list. So we have to return our answer. So let's talk about the time and space complexity. So we have this for loop, and we are only iterating if the value is unvisited. So it is n cross n, and on the next cell, on the next for loop, we have n cross n also. So its total time complexity is n cross n, and the space complexity, the maximum space complexity we have is n cross n. So that's all. If you still have any doubts, feel free to ask in the comment section, and thank you all for watching this video.